Today we'll talk inverses of trig functions. We've already kind of done this. If I asked you, well, what kind of theta value gives you a x value of root 2 over 2, you'd go over to your unit circle and say, well, pi over 4 gives me 1. And then you'll notice also at 7 pi over 4, I have another x value of that. Now in geometry, to solve for theta, we basically took the inverse of both sides. Now the inverse is also sometimes referred to as the arc. So this is inverse cosine and this is arc cosine. They're actually the same two things. But we get all these values from our unit circle. Now, if I ask you again, where do I have a 1 over y value equaling to 2, then I'm looking for y values of a half. And you'll notice I have one at pi over 6. And I have another at 5 pi over 6. And in theory, anytime I add 2 pi to one of those, I also have theta values that are equivalent to the inverse cosine of 2. So if they're just asking me to find theta, I've got infinitely many answers. Likewise, if I want to find the inverse tangent of root 3 over 2, I'm looking for a y value of root 3 over 2 over a half, which gives me root 3. All right, so this is my y and this is my x. And they either both have to be negative or both positive. So that's at pi over 3. And you'll notice right here, that has the same value and it's pi away, so every time I go pi n, multiples of that, I also get a value. Okay, so we're asking questions that have infinitely many answers in a case like this. So you'll notice in the inverse sine graph where I take the x and y, switch them, and solve for y, you'll notice here is a graph of the sine function. And here is the graph of its inverse where I switch the x and the y coordinates. And you'll notice it doesn't pass a vertical line test. So over on the right here, I have an actual inverse sine graph that does pass a vertical line test. And you'll notice that it floats between pi over 2 and negative pi over 2. So my output answers for a given sine graph go from negative pi over 2 to pi over 2. And this is now going to be the implied answer if they ask for an inverse and don't state over which bounds. You'll notice the domain in this case goes from negative 1 to 1. But this is where my answers are going to come from. Now, if I do the same for the cosine graph, it will also repeat itself. But in this case, it repeats itself in a different interval. And you'll notice that interval goes from 0 here to pi. These are the output values for inverse cosine, over again that interval of negative 1 to 1. Tangent's a little bit different story. Again, here's the graph of tangent, and then in the blue is the inverse, and here is the inverse function. Again, all isolated by itself. You'll notice its answers fluctuate between negative pi over 2 and pi over 2. And then the domain in this case ends up being all reals. So what did all that just tell us? Well, it tells us the following. We can consider this inverse domain or inverse range answers. All right, if I want to give answers for an inverse sine, cosecant, tangent, or cotangent, those answers may only be between pi over 2 and negative pi over 2. Whereas for an inverse cosine or secant value, those answers may only be between 0 and pi. These are implied values when you see the inverse. And we're going to do a couple examples in which case it gives the implied situation. So when they say find the exact value of the expressions, I know we did some of these earlier in the day, but we didn't have this new information. So now what this inverse means is that I may only give you answers between this negative pi over 2 and this pi over 2. So where do I have a y value of root 3 over 2 between negative pi over 2 and pi over 2? Well, that's at basically 60 degrees, right? Or up at pi over 3. Likewise, where do I have a negative tangent value? And that again is between pi over 2 and negative pi over 2. That's down here somewhere, all right? And that's going to be at negative pi over 4. Again, we want to find the exact value of the expressions. Now, this is a totally different setup. You'll notice they're asking you for a sine of pi over 13 of the negative type, and I have no idea where that is. All right, I can't tell you what the y value of this is going to be, but I do know that if I were to draw my graph, it's somewhere over here, and it says, finally, in the second part of the parentheses, what angle gives me that y value of this statement? Well, that angle is just negative pi over 13 in this case. And that seems kind of, intuitive. But when I come over to this problem, it's going to be a little bit different. And here's why. They're asking me to find the tangent of 6 pi over 7, which is somewhere over here. I can't tell you the y over x value of that because it's not a unit circle problem. But they want to know what angle gives me that value. Well, I know there's a reference angle right here of pi over 7. All right, and the problem is I can't state, well, your answer is 6 pi over 7 because I have this implied inverse tangent. I can only get answers from this part of the circle, which goes from pi over 2 to negative pi over 2. Well, that reference angle of pi over 7 is going to yield the same y over x value as 6 pi over 7 does over here. Therefore, we state our answer is going to be negative pi over 7. Do a couple more. Very similar problem. I will want to find the cosine or cotangent, sorry, of 10 pi over 7, which I can't. I don't know where that x over y specifically is, but I know 10 pi over 7 would be somewhere over here in the third quadrant. I know this has a reference angle of 3 pi over 7, and I know that the cotangent value in the third quadrant is positive. Again, I can't give this inverse answer in the third quadrant. It has to be somewhere in the first quadrant. Where is that somewhere? Wherever that reference angle was, at 3 pi over 7. And 3 pi over 7. So this next example talks about cosine values, in which case I'm going to set this up already. I can only answer a cosine value in the first or second quadrant between 0 and pi. And the quadrant that this is in is somewhere under 2 pi, because I know this is 48 pi over 24. All right, and if I were to divide 48 up into fourths, that would be 12 a pop. So this is somewhere in this quadrant, in which case to get to 48, if this is 41 pi over 24, my reference angle in this case is going to be 7 pi over 24. Now the cosine here is positive, so the question is, what angle in the first or second quadrant gives me the same x value as 41 pi over 24? Well, that's its reference angle of 7 pi over 24, which is in the first quadrant, somewhere over here.
So these next problems will require a calculator. One of the things you need to make sure on the calculator is you got it set in the right mode. Our book's going to ask for answers typically in radians. So if you hit your mode button, you should make sure you're in radian mode, which I am. I'll quit that. And then it's just a case of typing it in as you see it. So we take the inverse cosine, second cosine, 0.74. Get a value of 0.737-ish. And then we go, and in this case, we're going to take the inverse tangent of negative 8.27. And I better get a negative answer out of this because it should be somewhere in the fourth quadrant, which is a negative radian measure. So when I hit enter, you'll notice I get a negative 1.4. Now, in this case, you'll notice we're taking the inverse tangent of a negative number, and we just got done saying, well, for sine, that would be undefined. But if we look at tangent, all right, we know tangent has an undefined range. So we can always find what angle gives us a very large tangent.